Looking at switches, and I have an example right here. A switch is easily identifiable because it has a lot of ports on it. It's one of the most common items in a network. It allows you to connect all the different hosts to each other and then also to connect them to other switches or routers or other devices within your network. These switches are actually operating at the data link layer. So that's the second layer in our OSI model. So that's right there is where we're operating with a standard switch. And below that, if you weren't operating a switch, you would be running a hub, which operates at the lower level there, the physical layer. And then above that, at the network layer, would be a router. When selecting a switch, there are several things to look at. So the first one here is the number of ports on it. So depending upon how many devices you need to hook up, you need enough ports for all those devices, or you may need multiple switches. The next item there is the speed of the ports. So you can get a 10, 100, 10, 100, 1000, or a gigabit switch. So the more traffic you're sending through, the higher speeds you're going to want, but at the cost of a higher expense as well. Next is the form factor. So the one I have here, this one's really just designed to sit on a desk. The other form factor you can get is a rack mountable, and those come in different sizes depending upon how many ports and other features are part of them. So you need to really determine where the switch is going to sit, whether it's on a desk or in a wiring closet. The next item is the auto MDI/MDIX. So having that feature means that you don't have to worry about when to use a crossover cable or a straight through cable, because the switch will actually renegotiate how that port should be in order for traffic to travel across the wire you use. Next, the backplane speed. So that is actually the speed between all the different ports within that switch, or potentially between switches. So that speed is generally a lot higher than what your port speed is, because that speed is shared across all the ports. So the higher the speed, the more multiple traffic can work across this switch. Finally, the MAC address table size, and that's how many MAC addresses can be stored inside the switch. A switch operates by keeping track of the MAC addresses of the devices, or the data link addresses. MAC addresses are used in a standard TCP/IP Ethernet network. So as traffic comes across this switch, it starts keeping track of which ports those devices are on. That way, instead of like in a hub environment, it doesn't send the data out every port. It starts learning your network, keeping track of those MAC addresses, and the next time a piece of traffic comes into the switch and it knows that MAC address, it just sends it out that one port. Another term, which is not conducive with the OSI model, is a layer 3 switch. So traditionally, when you hear the word switch, you should think layer 2, the data link layer. Some people refer to a switch that actually has routing features in it, or has a router as part of the switch, as being a layer 3 switch. Really, it's a switch plus the routing capabilities. And as I had said just recently, a router operates at layer 3. So if you hear of a layer 3 switch, all that is a switch with added routing capabilities. But traditionally, if it's a switch, it is identified as being a layer 2 device.